through, and it gives you the sine of A, cosine of minus 120 degrees, and it gives you something over here on the right. So I was mentioning that you really want to know your unit circle really well. And in particular, you want to know the first quadrant really, 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 really well. You want to know that that's 1, 0, that that's 0, 1. And then there are 3 places on the unit circle that you just have to know. And the first one's at 30 degrees, 45 degrees, and then 60 degrees. These are the points 1/2 root 3 over 2, root 2 over 2, comma root 2 over 2, and then root 3 over 2, comma 1/2. I think you've seen this before, but if you haven't, please let me know. Have you seen, I don't expect you to be like an expert at it, but do you remember the unit circle?
Yeah, it looks a little familiar.
Okay. So we'll do a bit of review before we jump into like how to do this problem. But let me grab that reference sheet and I'll put a link in the chat to it. So on, I think it's page 3, there's a unit circle. You'll definitely want to have that up.
Page 3. Okay, I see it.
All right, so okay, so a couple of things here. When you're looking at the unit circle, and I'll probably just snip in this one. It's the first quadrant's a little nicer than what I have here. What we can do is I can ask you things like, what is the sine of 30 degrees? Okay, and the sine of 30 degrees, you have to go to where the 30 degrees is. You look at this ordered pair. The sine is the y value, so the y value is 1/2. Okay, the cosine of 30 degrees is the x value. The x value there is root 3 over 2.
Okay.
Now the tangent of 30 degrees, this is where you have to know a bit more. You have to remember that tangent is y over x, okay, or it's sine over cosine, but it becomes 1/2 over square root 3 over 2. Now this is related to some fraction stuff we did in an earlier lesson. When the bottoms are the same, it becomes 1 over root 3. And you probably remember that we have to rationalize this. We have to say, okay, it's root 3 on top and bottom, so it becomes square root of 3 over 3.
Okay.
Any questions on that for the moment?
Could I see just like another example of it?
Yeah, we're not gonna
Okay.
we're just gonna do this for all of the angles here. So like the let me see, what did I start with previously? Did sine, sorry, make sure I know what I'm starting with. So sine of 45 degrees, okay, is, so you look at the 45 degree here, and it's the y value, so it's root 2 over 2. Okay, what is the cosine of 45 degrees? Well, it's the same deal, but it's the x coordinate now. They happen to be the same, and that does happen from time to time on the unit circle. But what we're trying to get you to see here is that sine is the y, cosine is the x, and tangent is 2 things. It's either sine over cosine, or it's y over x, or both. Like they all work. Okay, it's you know, there's multiple ways to do the same thing. So however you want to look at it, it's root 2 over 2 over root 2 over 2. And when I say y over x, or when I'm referring to x and y, I'm referring to the ordered pair here. I'm referring to x comma y as an ordered pair. Okay, and since root 2 over 2 over root 2 over 2 are the same, this is 1. Okay, so let's look at it. Let's look at it now at 60 degrees. So at 60 degrees, right up here, 60 degrees, you're looking at this ordered pair. The sine of 60 degrees is the y value. The y value is √3/2. The cosine of 60 degrees is the x value, 1/2. Okay. And then the tangent of 60 degrees is √3/2/1/2. Because the bottoms are the same, you can just grab the numerators, √3/1 or just √3. Any questions on that? We're going to apply some of that to the units. We're just going to look at the word first quadrant for right now. But any questions or anything you'd like me to cover again?
I don't think so.
Okay. So just to see where you're at here, can you tell me what the sine of 30 degrees times the cosine of 60 degrees? Can you tell me what that is, please?
Sine. Is it 3/4?
So let's start with the sine of 30. The sine of 30 is the y value, 1/2. Do you see that? Sine of 30 is the y value. Okay. The cosine of 60 is the x value.
Okay, so 1/4.
So yeah, so that's just 1/4. Okay, so let's try another one here. How about the tangent of 45 degrees times the cosine of 0 degrees?
How do you like determine which one it is for like sin or tan?
Okay, so we was trying to make this like there's just a system, it's not clear. The x coordinate is cosine, the y coordinate is sine.
Okay, so sine is y, cosine.
Yes, exactly. And that's what you have to get. That's what you have to get very clear before going to this. So like when we look at this problem here, actually let me copy this down. So we're just looking at a fresh thing here. When we're looking at this problem, what I would do is I would say, okay, well, tangent is really sine of 45 over cosine of 45. And then sine is y, cosine is x.
Okay.
So sine 45 is the y value, cosine 45 is the x value. Do you have an answer for me or do you need some more time?
Is the answer just 1?
Yes, because the tangent of 45 is 1 and the cosine of 0 is 1. So yeah, it's 1 times 1, it's just 1.
Okay.
Okay, so let's try another one here. Let me grab the unit circle here. First quadrant. So let's go square root of 3 times the sine of 60 degrees plus 2 times the sine of pi over 6. So try not to make this, it is a little more complicated, but I'm still just basically asking you to look up each of these. So the first one I think you can find pretty quickly. You're going to see both radian and degrees on your standardized tests. You're also going to see that in your math classes in school. So you'll have to get comfortable with that they're the same. 30 degrees is really pi over 6. So you can visualize it as this, but at some point you want to recognize they're the same. You don't want to.
Okay.
Do you have an answer for me?
Is it 5 over 2?
Okay, so before I answer that, what did you get for the sine of pi over 6?
I got 1/2.
Perfect. So yeah, it's 3 halves plus 1, which is 5 halves. Perfect. Okay, fantastic here. So now here's some things that I did not, and I'm going to bring them up now just to help increase the complexity of this. I can also ask you about things like the cosecant of pi over 6. Okay, now what is the sine of pi over 6? Let's start with that.
1/2.
It is 1/2. So cosecant is the reciprocal of that, or it's 1 over. You can think of it's 1 over 1/2, or the reciprocal. I think the reciprocal is better, 2 over 1. Okay.
Oh wait, so sine. Oh, so it's just the reciprocal of.
Yes. So secant of pi over 6 is the reciprocal of cosine of pi over 6. So cosine pi over 6 is square root 3 over 2. So secant is the flip of that. It's 2 over the square root of 3. But by now you can't leave it like that. You have to rationalize. You have to multiply the top and bottom by root 3. So it's 2 root 3 over 3.
Okay.
And so same with tangent. So the tangent of pi over 6, okay, it is it is y over x. It's the 1/2 over root 3 over 2. So it's 1 over root 3. Okay. But when you get the cotangent, pi over 6, it's the reciprocal of that. So you flip this, root 3. So you might be wondering, well, why is he showing me all these things? Because there's really little, there's unlimited combinations of numbers and questions that you could be asked here. But we'll try, we'll keep trying to, we'll do a few here. So let's do this. Let's go cosecant of pi over 6 times the cotangent of pi over 3. Okay, so encoded in this question is like, what is the sine of pi over 6? And you would say it is 1/2. So the cosecant is the flip of that. The cosecant of pi over 6 is 2. Great. Now we have to do the same thing for cotangent. So you start by, well, what is the tangent of pi over 3? So that's up here. So tangent is y over x. It's root 3 over 2 over 1/2. Which becomes just root 3 over 1. And then cotangent is the flip of that. So you flip it. You go 1 over root 3. And then you rationalize. You say, okay, it's root 3 over root 3. So it's root 3 over 3. So the cosecant of pi over 6 is 2 times cotangent of pi over 3, which is root 3 over 3. So your final answer is 2 root 3 over 3.
Okay.
Okay, so let me give you one here to try. Let's have you try the cotangent of pi over 4 plus the secant of pi over 3. Have you try that, please. How are you doing on this one?
So for tangent, I got 1, but how do you like write the reciprocal of that? I'm kind of like blanking.
Yeah, so you can always write something as over 1.
Okay.
Doesn't matter what it is. If it's 10, if it's pi, if it's a billion, you can always write it over 1 and it's the same. That should help you to flip it to get the reciprocal to get cotangent.
Is cotangent 1 and then the other one is 2?
Yes, that's 1 plus 1 over 1/2, which is 2. So the final answer is 3. Okay, good. All right, let me give you let's give you another one here. So another possibility is I could ask you something else. I could say, what is the sine squared of 60 degrees minus secant squared pi over 4. Okay, so I'll do this one with you just so you can get a feel for this. So this 2 right here, like, and this is just the way that math people notate it for compactness. But what it really is you find the sine of, you determine the sine of 60 degrees, and then you square it. But it's written this way, and I don't know if you've seen that or not, but it's purely like a notational thing.
Mhm.
You can probably appreciate why it's there for compactness, but as a student, you're like, why can't it be there? I don't have the answer to that, but this is how you do it. So the sine of 60 degrees is √3 over 2, and then you square it. So when you square a square root, it undoes the square root, but the 2 on the bottom gets squared like that. Is that okay?
Okay.
Okay. Now secant squared, kind of the same deal here. It's first, it's the secant of pi over 4, but then you square it. Secant is really 1 over cosine pi over 4. So you have some choices here. And this is where it's kind of personal preference. You know, what do you see? You can either find the secant of pi over 4, you can find the cosine of pi over 4. You got to square it eventually. So let's do it this way. So it's √2 over 2, but then we're squaring it. So when you square the top, it's obviously it's 1. When you square the bottom, it becomes 2 over 4, which is 1/2, and then you flip it. So if you flip it now, it's 4/2, which is 2. So this becomes 3/4 minus 2. 2 is 4/4. I'm sorry, 8/4. So the answer is minus 5 over 4. But for really what I need to know, if what is clear here is, because this is the last kind of problem type that you would see, is this squaring. Do you feel like you understand how to work through it, that you figure out the value and then you square it? A lot of times these are chosen on standardized tests because it gets rid of the roots.
Mhm.
And same thing with reciprocals, though. You either find the secant of pi over 4 and then square it, or you change it to cosine, 1 over cosine. It's totally up to you.
Okay.
Okay, so let's have you try one here. I'm not going to make it. I don't want. I mean, the pointers to make these so difficult. It's just to get you to practice. So let's go cotangent. Sorry, let me grab that. I'm not gonna. That's the second part. Let's go. Yeah, let's actually do this. Let's go cotangent squared pi over 4 minus cosine 30 degrees, cosine squared 30 degrees. Okay, so try working through that. If you have any questions along the way, let me know.
Okay. Is it 1/4?
Yes, that is correct. Perfect. Very good. Okay. I know this probably isn't super interesting because it's very, I mean, mechanical, but we have we have a lot of time left. Do you want me to do you want us to switch topics, or do you want to kind of do like the get, because the goal here is to be able to do a problem like this original one, and it requires a bit more than what we've done here. But it's okay if we don't, because we've made good progress on this unit circle stuff. So you tell me, do you need us to transition to a new topic, or do you want to keep rolling with this one?
Um, Can we transition and then maybe like come back?
Yes, I don't know if I'll have time to come back completely, but sure, absolutely. So
Okay.
let me go find some stuff for us to work on. Let me see here. Maybe we can review some questions that you've done. Here. Okay, actually, this is a good, we've done some systems, we've talked about lines, but let's look at a new type of problem that I think, because we've done this for this, it's really not too much new. So it says, the question is for what value of k makes the lines parallel? And you're like, okay, there's k, there's two lines, great. So what do you know? What do you remember about lines being parallel? What is the requirement for that?
That they never cross.
That is true. They never cross because they're, what's the word? They're parallel. So they have the same slope. The same slope. Okay. And you get slope when the equations are in y equals mx plus b form. Okay. So I'd like you to just give this a try here. I know you haven't done this in a while, but I want you to solve that first equation. I want you to solve it for y. Solve it for y. Get y by itself, please. See if you can tell me the slope of that equation. How are you doing on that?
I think I need a quick refresher on how to do this.
Okay. So the equation is minus 4x plus 7y equals minus 2. So you're gonna first add 4x to both sides. And it's my preference, but I like to put this before the other number, even if it's negative. So it would be 7y equals 4x minus 2. And the reason is because you want it in that mx plus b format. But it's got to be solved completely for y. So you divide both sides by 7. And it's not a choice. You have to divide both of them by 7. So it's 4/7 x minus 2/7. Maybe this is where it was uncomfortable because it didn't work out nice. It wasn't like, oh, it's a nice number. The slope m is the number in front of x. So the slope in this case is 4/7. But that's not the answer, but that is the slope of the first equation.
Okay.
Okay. Now the second equation, actually, let me grab it. So the second equation here, I'm going to just give myself some fresh space here. 4x plus ky equals minus 2. Same deal here. You want to solve for y. Okay. So you're going to subtract 4x from both sides of the equation. And again, my preference is to put it in front of the number. So it's minus 4x minus 2. And then this is probably even more awkward. You're dividing by k. K is a number. We don't know what k is, but we're dividing by k. Y is now minus 4 over k times x minus 2 over k. So the slope here is this thing right here. It's minus 4 over k. So the slope from the first line was 4/7. Yeah, 4/7. The slope of the second line is minus 4 over k. For them to be parallel, what has to be true? What did we say earlier? These have to be
the same slope.
That means they have to be equal. Yeah, they're the same. So you're solving this now. To solve this, you cross multiply. Now, remember, it's a synthesis. Like there's always like multiple like little things that you're being asked for on these standardized tests. You're never just asked to do one thing. It's always a couple. And then you divide by 4. So k equals -7.
Okay.
So if we go back and sort of summarize, like, well, what do you do to solve a problem like this? You have to know that the lines are parallel. Okay, that's really important here. If they're parallel, they have the same slope, which means you need the slope of one line, and then you have to find the slope of the other, and then you set them equal.
Okay.
So let me grab another question like this one, and then we can work through it. Try and find one that's kind of similar with some nice numbers. Yay. Okay, we'll try this one. Okay, so here's the question, and let me make this easier to see. All right, so I'm going to step you through this. The first thing I need you to do is I need you to solve this first equation for y. Okay, so you're gonna subtract the 3x from both sides. You're gonna divide by -2. Yeah, it's a fraction. That's okay, but go ahead and solve it for y for me. Let me know when you're done with that. All right, do you have an answer for me on this one?
Does y equal 3?
Well, okay, you're solving. Okay, so you're solving for y, the first equation. So 3x minus 2y equals -9. You subtract 3x from both sides of the equation.
Mhm.
And so it becomes minus 2y equals, and this goes in front, minus 3x minus 9. And then you divide both sides by -2. So it's minus 3 over minus 2 times x minus 9 over minus 2, like that. So you got 3 halves x plus 9 halves there. Do you see where you differed from the work here?
Yeah.
Okay. Now look, maybe on the standardized test, you get a number over here like 6, where when you divide, everything works out. And but that's not, I mean, we're working on fractions. You're going to get some fraction problems here. This is a good thing. So the slope here of this equation is 3 halves. Great. That's not the answer. Okay, but now you got to go back to the second equation right here, and you have to solve it for y as well. So you do the same thing. You subtract 2x from both sides of the equation. And my preference is to put that in front. I can't stress that enough. It will help avoid not giving the right slope. Okay.
Okay.
And then you divide by 5k. Now, another way you can do it is you can just immediately write 5k, or whatever you're dividing by to each one. So y is equal to, and this is probably the most awkward part, is it's -2 over 5k times x plus 12 over 5k. You actually, what's interesting is if you were to do a bunch of these in a row, you'd eventually realize you don't even care about that. This is all you care about right there, because that's the slope of the second equation.
Okay.
And you want to set that equal to the slope here. These have to be equal. So we set -2 or 5k equals 3 halves. You cross multiply, you get -4 equals 15k. Divide by 15. So k equals -4. I'm sorry, k equals -4 over 15.
Okay.
Yeah, so maybe, I mean, you might feel like, okay, there's a lot here. Yeah, there kind of is, but it's all stuff you know how to do. You know how to solve for y, you know how to find the slope, you know how to find the slope of the other one, you know how to solve this little equation here. There's fractions, but you can do all this. So let me have you try one on your own here and see how you do here. So let's How are you doing on this one?
I think I did something wrong because I got -5 over 21.
Okay, so let's look at the first, I'm sorry, we'll do the second equation. So if we solve that for y, you end up getting y equals 5x minus 6. Then you divide each of those by -5. So you end up getting 5 over -5 is -1x. And then the other one you actually don't care about. So the slope for the first one is -1. Did you get that? Or for
Yeah.
the second is great. So for the second one, you get y equals -2x plus 11, and you divide it by -7k minus 7k, and the negatives cancel. So it's 2 over 7k equals -1 over 1. And so if you got this far, which I'm not sure if you did, but if you did get this far, you would then cross multiply. 2 equals -7k, divide both sides by -7, and k equals -2 over 7.
Okay, that makes sense.
All right. Again, like if you feel like, well, why can't I get this, or ask yourself that, there's a lot here. You really got to be comfortable solving, knowing when to simplify, dealing with signs. If these were both in this form, if they're in the form of like y equals 3/4 to x plus 1 and y equals 1 over k x minus 1, and you just set them equal to each other, this is too easy, because and it's not testing any knowledge of this. So it's just an added extra step, since they're in standard form, to convert them to slope intercept form.
Okay.
So, again, just keep in mind, like, these are probably, and I'm just crossing out because they're not related to this problem. These are probably more difficult than what you will see, but they're good preparation for it. Okay, well, I think that takes us to the end of our first lesson for today. Can you let me know what we're going to be working on during the next hour?
Yeah, so I have an algebra 2 diagnostic on either Wednesday or Thursday, and he sent like a packet of all the questions, and I would
Okay,
just like to review it because we're not really doing the best job of reviewing it in class.
understood. All right, well, I will see you in about 10 minutes, and we'll do as much as we can.
Okay, thank you.
You're welcome. Bye now.